Can you solve this problem?
Wait, you're not going to expand everything term by term, are you?
No way. That would be far too tedious. Instead, let's use the idea behind the binomial theorem. But before that, let's quickly review what expansion really means. For example, when we expand a plus b squared, which is a plus b times a plus b, we choose either a or b from each part, multiply the choices together, and then add up all possible combinations. Does that make sense?
Yes, I understand. For example, if I choose A from the first place and B from the second place, I get A, B, right?
Exactly. And you just add up all the possible combinations.
Got it.
Now, the same idea applies to a plus b to the sixth power. From each of the 6 positions, you choose either A or B, multiply all 6 choices, and then add up every possible combination. For example, if you choose A from the second and third positions and choose B from all the others, you end up with a squared b to the fourth power.
I see. So that means, anytime you choose A exactly 2 times and choose B exactly 4 times, the result becomes A squared b to the fourth power. Is that correct?
Perfect. Then let's figure out the coefficient of A squared b to the fourth power. Do you know how we can think about it?
Well, the term A squared b to the fourth power appears many times.
Exactly. So how many times does it appear? For example, if you place A in the second and third positions, that gives you something like B A A B B B. You could also choose A A B B B B, or A B B B B A, and many other patterns. So how can we count the total number of ways to produce A squared b to the fourth power?
Oh. We just need to count the number of ways to choose 2 of the 6 positions where A appears. So there are 6c2 possible choices. That means the term A squared b to the fourth power appears 6c2 times.
Perfect. Choosing the 2 positions where A appears gives us 6c2 possibilities. So the coefficient of A squared b to the fourth power is 6c2.
Or we could choose the 4 positions where B appears and compute 6c4, right?
Exactly, both give the same result. So, what's the final coefficient?
Let me calculate 6c2. That equals 15, so the coefficient is 15.
Excellent. The binomial theorem might look complicated when you write down the formula, but once you understand the meaning behind it, you can solve problems like this without memorizing anything. Now, let's try a practice problem. Do you think you can solve it?
I think so. To get A to the fifth power b squared, I choose A 5 times and choose 3b the remaining 2 times. The number of ways to choose those 5A positions is 7c5. So the answer should be 7c5.
You're close, but take a good look. This time it's not just b, it's 3b. Doesn't that change the coefficient?
Oh, right. If it's 3b, the coefficient should get bigger because of those 3's.
Exactly. So, how can we build the coefficient?
Let me think. We choose A 5 times and 3b 2 times. So every such term looks like A to the fifth power times 3b squared. And the number of ways to choose those 5A positions is 7c5. So this term appears 7c5 times, so we just multiply by 7c5. So the full coefficient is 7c5 multiplied by 3 squared.
Perfect. Now just compute that value, and you have the final answer.
Okay, since 7c5 is the same as 7c2, it's easier to calculate it that way. And when I do, the answer comes out to 189.
Exactly. Perfect understanding. Now here's your homework, try the next problem on your own, and leave your answer in the comments. And if you thought this video was helpful, don't forget to like and subscribe. More clear and fun math tutorials are on the way, so stay tuned.